All right, so this problem is two-sum. I'm going to be doing it in Python. It says, given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Then I give you a couple examples. So in example one, we have a input list or array, whichever you prefer to call it. I'm gonna call it a list since this is Python. So we have an input list with the elements 2, 7, 11, and 15. The target is 9. So of course the output is a list with the elements 0 and 1 because these are the indices we would need to add to get to the target. And that is what they have right here in the explanation. In example 2, we have an input list with the values 3, 2, and 4. The target is 6, so the output, of course, is a list with the elements 1 and 2 because this is what we would need to add to get to the target. And example 3, the same, we would need to add 3 to 3 to get 6, so of course we get an output list with the elements 0 and 1. Then they have a list of constraints, so the length of our nums array is greater than or equal to 2, but less than or equal to 10,000. Nums of I, or the values inside of our array, is greater than or equal to negative a billion, but less than or equal to a billion. And our target is greater than or equal to negative a billion, but less than or equal to a billion. And only one valid answer exists. And as a follow-up, can you come up with an algorithm that is less than O of n squared time complexity? Okay, so I'm going to show you two ways to do this. The first algorithm has a time complexity of O of n squared, but it has a space complexity of O of 1 because we're not going to really need to allocate a variable amount of memory. Either we're going to have a solution or we're not. But with the second approach, it has a time complexity of O of n. So as far as the follow-up, you would use the second approach if you wanted to come up with an algorithm that scales less than O of n squared. But it has a space complexity of O of n also because we're going to use a map, and depending on however many elements we need to add to the map, we're going to need to allocate space for them or for the elements. So of course that means n elements, n amount of space, O of n space complexity. Okay, so with the brute force approach, what we're going to do is we're going to have a base element. So in this example will be 2. And then we're going to add all the other elements to the base element. So 2 plus 7, 2 plus 11, and 2 plus 15. In this case, since it was 9, we would get the solution within like with the first iteration. But let's say that, for example, we had to iterate all the way through the list, and it would go 2 to 7, 2 to 11, 2 to 15, and then the next number would be 7, and then this would be the base, and it would be 7 to 11, 7 to 15, and then so on and so forth. Okay, so first we're going to use a for loop that's going to represent the base element. So for I in range 0 to the length of our nums array, for j in range I plus 1. Oh, I'm sorry, gotta put the comma here and then put the length of nums. Okay, so what happens here is this is going to be the base element, so this will be 2, and this is going to complete all of its iterations. So it's going to start 1 after the base element because we cannot use the same element twice. So we're always going to start one element after the base. So now that we did this and we're going over the length of our nums array. So remember the length of our nums array is 4. So if we were using this example, it will be 4. So since this value will be 4 and this value will be 4, we're obviously only iterating 0, 1, 2, and 3. So we're only iterating to the end of the array pretty much. Now, what we're going to do is if we do in fact have the solution, we're going to return a new array with the indices like you see here. So if nums of I plus nums of j is equal to our target, then we're going to return a new list or a new array with the indices of I and j. So again, base element iterates over all the other elements. Then we check to see if we add to get to the target, and if we do, we return those indices in an array. And then I'm going to run this to make sure it runs smoothly. If my internet would hurry up. Okay, now I'm going to submit this. And anytime today. Okay, so 2421 milliseconds beats 37.97%. And as far as memory, we use 14.2 megabytes, and this beats 69.14%. Now, what I'm going to do is I'm going to close this. I'm going to go back to the description. Okay, so with the second approach, remember we're going to use a map, so we're going to have to add these elements to the map. Now the difference between this approach and the last one is instead of us having to use two for loops, we can only use one. And as we go over the list or the array, we can add the elements. So on the first iteration, I'm not going to have anything in the map, obviously. It's going to be a new map. So then I'm going to add two. And then when I get to 7, I'm going to check the map to see if I have the complement. The complement is the number we need to add to 7 to get to 9. So of course that would be 2. So we would have 2 in the map because we iterated over it and we added it to the map because it was empty at first and we didn't have the complement. So we added it to the map. Now that it's in the map and we're on 7, we have the complement. So we would just pull the indice of 2 out of the list of our nums array out of our nums list, I should say. And we're also going to get this index right here. So we need this for loop to iterate over our uh, nums array. And well, actually, before this, what I'm going to do is I'm going to create the map or the dictionary. So map is equal to new map. Maybe tab this over. What's going on here? Press enter, and then I'm going to make the complement. So remember, the complement is the number we need to add to nums of I to get the target. So complement. Oh, well, actually, first, what I'm going to do is I'm going to change this range to enumerate because we need to enumerate over our list so that way we can set an index to the key, and the key is going to be the number in this case. So enumerates, and then we're going to enumerate over our nums list. So for index and number and enumerate. So what's going to happen here is let's just use um, this list right here. We're going to enumerate over our nums list. So we're going to do something like this. We're going to have an index, and then we're also going to have the number that is in the list. So 2, 7, 11, 15. Those are going to be the numbers that we're indexing pretty much. So 0 is going to be, if this was the example here, 0 would be 3. And then we would have two more of these. So let me see. Control V, Control V. I'm going to put a 1 right here. And then I'm going to put a 2 right here. And then this would be 0, 3. This would be 2. And this would be 4. Okay, so now that we have the index and we have the number, we can now just associate the key with the index. So that way, when we need to pull the complement out of the map, we do so by the key. And when we do it by the key, which would be this number, we would get the index, which is what we need to return in our new array or our new list. So after I enumerate this, I get the complement, which is our target minus the number. And then we're going to check to see if we have the complement in the map. If we don't, then we're going to add it to the map, or we're going to add this number, I should say, to the map. So if complement in map, then we're going to return a new list with our complements index first, and then the current index we're on. So I'm just going to put index here. So if we have the complement in the map, we're simply just going to get it, whatever it is, and that's going to be the index. So in this case, what is the answer here? 6, so 1 to 2. So that means that here the complement would be if we iterate to 4 to okay, I'm sorry. So here the complement would be 2. So we should get the number 1 first, and then right here, since we will be on the second index, we will get 2. All right, sorry about that. So that's if we have the complement. If we don't have the complement, so if complement not in map, then what we're going to do is we're just going to simply add it to the map. So nums, or we're not going to add the complement, we're going to add the number to the map. So nums, oh, well, I'm sorry, map of number is equal to index. So now we get the number, whatever it may be, 3, 2, and 4, and then we assign the index to it if it's not in the map. So it will be 0 for 3, 1 for 2, and then 2 for 4. Run this. Hopefully everything runs smoothly. And complement equals target minus number, unexpected indents. Oh Lord. Oh, well, probably because I didn't comment this out. Now everything should run smoothly. Okay. List index out of range. Oh goodness. Okay, so this is supposed to be map of complement. Sorry, you guys. All right, there we go. Finally. Okay, so accepted. Now let me submit this. If this would hurry up. Okay, so 91 milliseconds beats 74.56%. Memory 14.4 megabytes beats 22.78%. All right.